today I'm going to be working out of our free response packet. Pretty much everything this week is going to come from this packet. And I'm going to flip, and we're going to be focusing on the 2011 problem number 3. It's problem number 3, which means we don't get to use our calculator. So the problem says, let R be the region in the first quadrant enclosed by f of x, which is 8x cubed, and g of x, which is the sine of pi x. Let's first determine which one is which. On this graph, I know that an x cubed kind of curves up like this. So this bottom graph must be f of x, which was 8x cubed, leaving the top curve to be g of x, the sine of pi x. So I'm just labeling those so that I know which one is which. Part A. Part A asks us to write an equation, something we haven't done in a little while. Well, hopefully you remember whenever we write an equation, we need two things. We need a point and we need a slope. Well, I'm supposed to be writing the equation for the line tangent to f. So that's important that part A is only focused on f of x. And it tells me to do that at x is 1/2. So for my point, it's going to be 1/2 comma something. Well, if I look over here on my graph, it tells me that the point is 1/2 comma 1. It is a point that happens to be on both graphs. So it's definitely on f of x. Then I need to find my slope. Well, it doesn't tell me what the slope is in this picture. And so I can remember that slope is just derivative. So if I'm working with f of x, which was 8x cubed, and I need to find the slope, I'm first going to find the derivative, f prime of x, being 24x squared. And then I'm going to find f prime of 1/2 using good notation. 24, I'm going to put 1/2 in, and I'm going to simplify. To be honest, you don't need to simplify this. If you took this and just wrote it over here as your slope, you could get away with putting the slope here and writing your equation that way. I am going to simplify for anybody who did simplify. Again, you don't have to. If you chose to simplify, this would be 24 times 1/4, which is 6. So my slope is 6, but again, I could leave it as what I have underlined. Now to write an equation, I just put it into point slope form. Y minus 1 equals 6 times x minus 1/2. And that would be my answer for my equation. The way the points were awarded this year, if you came up with your slope of 6, you got 1. Another way is you could have left it as this 24 1/2 to the squared power. 1/2 squared, that would have also been okay. And then writing it all as an equation gave you your second point, earning you 2 points for part A. Part B asks you to find the area of region R. So whenever it asks me for area, I come over to my graph and I make sure that I can see that clearly one of the graphs is on top of the other. And I can clearly see that G is on top of F everywhere. So to find area, we always integrate top curve minus bottom curve. In this case, my top curve is the sine of pi x, minus the bottom curve is just the 8x cubed. Dx, my boundaries along the x-axis are 0 up to 1/2, so those are going to be my bounds of integration. Now we don't get to use our calculator, so I actually have to integrate this by hand. The antiderivative of sine is always negative cosine pi x, and then I do the inverse chain rule. The derivative of pi x is pi, so I'm going to divide by pi. Minus antiderivative of 8x cubed is 8x to the 4th over 4. So 2x to the 4th. I put my brackets on the end, and then I'm just going to plug in. Now remember, we plug in top minus bottom. When I plug in the top, I'm going to plug in 1/2. So I have negative cosine of 1/2 pi over pi minus 2 times 1/2 to the 4th power, minus, and then I'm going to plug in 0. Now be careful when you plug in 0, it actually turns into something. So I'm not just going to put a big 0 here. I'm going to say the cosine of 0 pi over pi minus 2 times 0 to the 4th. And I would suggest leaving your answer just like that and not simplifying. The way that points were awarded, you got 1 point if you correctly had this integrand right here. Then you got 2 points for taking the antiderivative. Likely 1 point for this antiderivative, 1 point for this antiderivative. And then your final answer was a 4th point. And so this was a 4-point part of the problem for part B. Okay, part C. Part C is one of the ones that says write but do not evaluate an integral expression for the volume of the solid when we revolve it or rotate it around y equals 1. So whenever we're revolving or rotating, we have volume equals pi integrate r squared. We're going to come up to the top and decide whether this one's going to be a disk or a washer. So if I come up on my graph, I'm supposed to be revolving around y equals 1. Y equals 1 is this dotted line that I've put at the top. There is a gap between the dotted line and this region, and so therefore it's going to be a washer. So when I set up my work, that means we're going to have an outer radius squared minus an inner radius squared. That's what we do for every washer. This line that I'm revolving it around at the top looks like the x-axis, or parallel to the x-axis, meaning dx, also meaning that my boundaries are going to be the x boundaries 0 to 1/2. So then we just have to figure out what our lowercase or our capital R, outer radius, and lowercase r, inner radius are going to be. So let's go up to our picture. And my outer radius is always measured from the dotted line. Doesn't matter where we start on the dotted line. We start on the dotted line and go through to the edge of the region. That's my capital R. Capital R is always going to be top minus bottom. Well, the top, I started at that red dotted line, which was 1. So my top is 1. Minus the bottom brings me to this bottom curve, f of x. At this point, I can write f of x right here and get full credit, or I can write 8x cubed, either way. My lowercase r is going to be measured from that dotted line. We always measure from the dotted line to the closest spot in the region. Call that lowercase r. And again, it's always top minus bottom. So the top starts at the dotted line, the red dotted line, which was up at 1, minus the bottom hits this curve right here. And remember that curve was the sine curve. So the sine of pi x. I don't need to simplify it because part C says write but do not evaluate. And how points were awarded. If you knew to have your pi in the front and your boundaries going from 0 to 1/2, you got 1 point. And then your integrand right here was worth 2 points, likely 1 for each. And you had to know to square each one individually and subtract the 2. So that was 3 points. All right, guys, thanks for checking in, and hopefully you will try our next problem tomorrow. Email me if you have any questions.